What's up? I'm Vin, and today I want to take a look at this algebraic Math Olympiad style question. So we have this question here, and the goal is to find the range of f of x, and we have these given conditions. So the strategy I want to go with for this question, the first things that come to mind when I read this is I think about what do we know about f of x? And at first glance, f of x is a rational function because a, b, c, and d are non-zero real numbers. And we're told that f of 19 equals 19 and f of 97 equals 97. So what I imagine here is that if I look at the line y equals x, that at 19, and this is not going to be drawn to scale, but at 19, we're going to hit this point at y equals 19. And then when x is equal to 97, y is going to be equal to 97. So we're going to be on the line y equals x. And another thing that jumps out here about this function is that f of x equals x, which means that this function f is its own inverse, except at x equals negative d over c, the function is undefined. So what I'm imagining here is that we have one location where the function is undefined, and that's going to make a vertical asymptote. But we're also going to have a horizontal asymptote, and the horizontal asymptote here is going to be equal to y equals a over c, because the leading terms, the leading powers of x match, so the horizontal asymptote is going to be equal to the ratio of the coefficients. So what I'm imagining here is a graph that is its own inverse, which means it has symmetry over the line y equals x, and it's going to have horizontal and vertical asymptotes like this. So this just gives me a rough idea so that when I start this question, I have an idea of what my answer is going to look like. So our range is going to be all y values except this horizontal asymptote. So now we're going to find that horizontal asymptote a over c. Now to go through this algebraically, first we should find f of x. And f of x we're going to find by plugging in the function for each value of x. So we're going to have a times x plus b over, and then we have c times x plus d. And what we're going to be plugging in place of x, we're going to plug in the function f of x. So we're going to have ax plus b over cx plus d, and then we're writing the same thing over here. So what we'll do from this step here is we want to get rid of these fractions in the fractions, so we're going to multiply the top and bottom by cx plus d. So we'll take it from this step. So when we distribute this here, notice when we multiply the first term by cx plus d, the denominator is going to cancel. The same way in the denominator when we multiply by cx plus d, this denominator will cancel. So now this is going to be equal to, we're going to have a times ax is a squared times x, and then plus ab. But once again, when we multiply by cx plus d, this denominator wipes out. And then we have b times cx plus d. So that's going to make plus bcx plus, and then we have bd over, and in the denominator, when we multiply this first term by cx plus d, the denominator cancels. So we have c times the numerator. So we're going to have acx plus bc, and then when we multiply cx plus d times d, we're going to have plus cdx, and then d times d is going to make d squared. And we were told here once again that f of x is equal to x, so we're going to set this equal to x over 1. And now what we could do here is we could cross multiply. But maybe right before we cross multiply, let's group some terms together. We could group together the x terms on top and the x terms on bottom. So once again, we're just grouping the x terms together, so that way when we cross multiply, things will be a little bit more organized. So we're going to multiply the denominator by x, and that's going to make, we're going to have ac plus cd x squared plus, and then we'll have bc plus d squared times x, and this is going to be equal to 1 times the top, which is just going to repeat the top. So we have a squared plus bcx, and then we have plus ab plus bd. The next, we're going to move everything to one side, so we can subtract a squared plus bcx on both sides. And then the next thing we're going to subtract over here, we're going to subtract over the ab plus bd. So now what we're going to have next here, when we subtract, the right side is going to equal 0. So we're going to have 0 on the right side, but now on the left side, we're going to have ac plus cd times x squared. And now the x terms, we could combine stuff here. We have bc minus bc is going to cancel. So out of the x terms, we're going to have d squared minus a squared left. So we have plus d squared minus a squared times x, and then we're going to have minus, we could factor out a b. We have minus b times a plus d. So now we have to remember our initial condition that a, b, c, and d are non-zero, and we have an x squared x in constant terms. So the only way the left side is going to equal 0 is if each of these are equal to 0. So we could take something like the last term here and say the only way b times a plus d will be equal to 0 is if this factor a plus d is equal to 0, which is going to imply that a is equal to minus d, which we could also say then that d is equal to minus a. So now what we'll do is we'll take our original function here. We have f of x was equal to, we had ax plus b over cx plus d, and we're going to replace the letter d with minus a. So we could rewrite f of x now as ax plus b over cx minus a. And now from this step, what we're going to do is make use of the initial conditions. We had f of 19 equals 19, and we also had that f of 97 is equal to 97. So now let's plug this into the function. We have f of 19 is equal to, and we're going to have 19a plus b over, and then we have 19c minus a. I'm going to use this second form of the function after we made our substitution. And we were told f of 19 equals 19, so we could set this equal to 19 over 1, and now we could cross multiply. And this is going to make 19 times 19 is 19 squared times c minus 19a. And when we multiply by 1, that's going to give us 19a plus b. And now we're going to do the same thing here with this initial condition. We're going to say f of 97, when we plug into the function, is going to give us 97a plus b over, and then we're going to have 97c minus a. And this is going to be equal to 97, which we'll write as 97 over 1. So now cross multiply, and we're going to have 97 squared c minus 97a is equal to 97a plus b when we multiply by 1. And now what we could do from here is we're going to make this into a system. Now we could rearrange these equations. We could write the second equation here as 97 squared c equals, and when we add 97a to both sides, that's going to make 2 times 97a, because we're going to combine those together, plus b. And then if we do the same thing with the second equation, we'd have 19 squared c is equal to 2 times 19a plus b. And now we're going to subtract this equation from the top equation. And notice on the left side we could factor out a c, and we have c times 97 squared minus 19 squared. And this is going to be equal to, when we subtract on the right side, b minus b cancels. We could factor out a 2a, and we're going to be left with 97 minus 19. And now we have to think back to before. If we remember what we said before, we said the horizontal asymptote in f of x is going to be equal to y equals a over c. So that tells me algebraically we want to solve for a over c, which are the only two letters we have left. So if I want to build a over c, I'm going to divide both sides by c to cancel this out, and now I'm going to move this stuff to the other side. So I'm going to divide by 2 times 97 minus 19. So we're dividing by 2 times 97 minus 19. And now things are going to cancel out here. We're going to be left with a over c, and we'll write this in simplified form. We have a over c equals, and notice on the left side we have a difference of 2 squares. So I'm going to factor at the top is 97 plus 19 times 97 minus 19 over, and we have 2 times 97 minus 19. Let's just make this parenthesis a little darker. And now notice 97 minus 19 could cancel on top and bottom. And now this is going to simplify here. That's going to make 116 divided by 2, which is going to be equal to 58. So now we could say here the range is all y values except the y value of our horizontal asymptote, which is 58. So the range is all y values except 58. So here's an alternate method. Let's say we didn't know the idea that the horizontal asymptote was the only y value that was missing. We could show it by solving for f of x explicitly. So first what we could do is solve for a, and we would have a equals 58 times c, and then we could plug that information into this equation. Then we could use this information here to solve for b. So now let's plug this information into the function. We have f of x equals, and we had ax plus b over cx plus d. But remember, before we said d is equal to minus a. So we could write this like this, but now let's just keep substituting. A is equal to 58c. So we have 58c times x. B is equal to minus 1843c. And then this is over. We have c times x minus a is equal to 58c. So what we could do from here is just divide the top and bottom by c. And that allows us to write this function as 58x minus 1843 over x minus 58. So now at this point here, we could see that the domain is x is not allowed to equal 58. And also the range, the horizontal asymptote is clearly y equals 58, so that would be excluded from the function. Now one last measure we could go forward with here is we could divide 58x minus 1843 by x minus 58 using polynomial division. So what this information allows us to do is we could rewrite f of x now as 58 plus 1521 over x minus 58. And from here, it's clear to see that f of x, the y value, could be anything except 58, because there's no way this fraction here, 1521 over x minus 58, will not equal 0 for all x. Okay, so for all x, this expression will not equal 0 because the numerator is a constant, so there's no way to make this fraction equal to 0. Therefore, we can conclude once again that the range is y can't be 58. Okay, so it's all y values except 58.